Hello everybody, and welcome to our talk, When Everyone's Dog Named Fluffy. Today we're going to talk about the brand new security question feature of Windows 10 and how it can be abused by attackers to gain domain-wide persistence. My name is Tom Sella. I lead the security research at Elusive Networks, and here with me is Magal, who is a researcher at Elusive Networks. At Elusive, we are creating deceptions to detect advanced attackers. Let's dive right in. As I said, we are deception researchers. Deceptions are basically pieces of information planted by defenders in order to trick attackers and detect them. And we researched a place called LSA secrets, which usually hold binary information. And while researching the LSA secrets, we stumbled upon that string. What was your first pet's name? That was kind of strange because we didn't expect to find such strings at the LSA secrets, and at that point we decided that this is interesting, we should dive into it to understand what is it all about. And the talk that you are going to hear is the outcome of our journey to understand what is this string and whether there are any security implications of it being there. So what was it? Windows introduced a new feature in last April, a security question feature. It enables local users to reset their passwords. They need to answer correctly 3 out of 6 predefined security questions. And as you just saw, the questions and answers are stored in the LSA secrets. A typical flow will go as follows. The user is unable to enter his correct password. It will be presented with a reset password button, and then it will be able to answer correctly 3 questions. It will be able to reset his password to a new password and gain access to his machine. And generally, security questions is not a new thing. They've been around for a very long time. It was initially used by financial institutes to identify their customers. In the early 2000s, it became widely used by many websites in order to enable users to reset their passwords. But nowadays, many question how secure are security questions. And most reset password mechanisms usually involve multi-factor authentication. And it made us wonder what made Microsoft decide to introduce such a feature in 2018. And because security questions, like passwords, enable users to gain access to a system, we want to compare how they are secured and whether the same mechanisms that were introduced to make passwords more secure were also applied to security questions. And we compare the implementation of the two at Windows. So passwords have complexity requirements and expiration date. The two does not apply to security questions. I do not know anybody that his mother's maiden name ever changed. From an administration perspective, admins can set GPOs that control how users will use their passwords, while the same does not apply to security question. We did not find any GPO or any kind of admin setting that can enable admins to control how users are using the security questions. From auditing perspective, there are various events that are generated whenever a user uses his password correctly or incorrectly. While the same does not apply to security questions, there is only one single event that is generated whenever a user resets his password, but there are no events that are created whenever a user creates or sets his security question. And lastly, from a social engineering perspective, we all know that passwords are not immune to social engineering, but the situation is much worse when it comes to security questions. An attacker can even get information online. You can access Facebook and find out what school you went to. And in recent years, there are many attacks that involve such a scenario of getting the answers for security questions in other means. And we want to know also how the community feels about this feature. And as you see, the reactions were quite enthused. Most of the Google search results involved how to disable the security questions. So far, we covered what is this new feature. But as security researchers, we want to know whether there are any security implications or Does this new feature introduce new attack surface? And we divided the situation into two. The first side, whether security questions can be used as a means to gain access to a system or escalate privileges. And of course they are. You can do brute force attacks and social engineering, but this topic was widely covered in the past. What we want to talk about today is whether security questions can be used as a stealthy backdoor. How would such a scenario go? An attacker, after already obtaining privileged credentials in the network, can remotely set the questions and answers of all Windows 10 machines in a domain. He can decide that everyone's dog named Fluffy. And from that point on, whenever he wants to regain access to any machine, he just needs to be able to answer correctly on the security questions. The answer will be Fluffy. And as we just saw, this is currently not auditing in any way. And generally speaking, this method is a persistent method, and many of the innovation in recent years shifted from how to obtain privileged credentials to how to keep persistence in a network even after you're getting detected, and making sure that no matter what happens, you will be able to regain your access into the network. And this is the topic of our talk today. How would such a scenario be possible? How an attacker could set everyone's dog's name to be Fluffy? You will need to be able to do the following things. You need to be able to reset security questions remotely. You need to be able to reset the password remotely. And lastly, change back what he did in order to go unnoticed. So what do you think? Can it be done? I'll let Magal answer that.
Thank you, Tom. So the quick answer is yes, it can be done. That's why we're here. It might be the place for a disclaimer. What we are about to walk through is not per se an exploit, but rather an abuse of mechanism in ways that the designer probably did not intend. So let's review our roadmap. In order to use security questions as a stealthy backdoor, we need to prove that we can do three things. Set security questions remotely, reset the password with the questions we've just set, and then revert the password back to what it was. Let's start with how to set security questions remotely. So as Tom mentioned earlier, security questions are implemented in the LSA secrets mechanism. LSA secrets is a safe storage mechanism in Windows. It is based on the registry, and it stores all kinds of things like machine password and DP API keys and all sorts of stuff. And if you want to access LSA secrets are basically, each secret is a registry key in which you have protected binary data. And there is an API to access LSA secrets, which allows you to set, open, create, read. It's pretty much like the API for working with files on Windows, only that here behind the scenes, when you perform a write operation, then the OS is going to encrypt the data and store it encrypted. And when you perform a read operation, then the OS is going to decrypt it for you. Now, it is encrypted in AES. And the encryption scheme is quite complex, but the important issue, it's not an issue, the important thing to understand about how it is encrypted is that in order to assemble the AES key with which the LSA secrets are encrypted, you need to collect artifacts from the registry on that machine, assemble them, XOR them, manipulate them in several ways, and from this data you can recreate the key with which those secrets are encrypted. So if you have full access to the registry on the machine, it's really not that difficult to get the key with which you can read and write LSA secrets. Now, there is another problem. In order to access those parts of the registry, you would need to have a system account. And that's a problem, because what we want to do is access the LSA secrets remotely, and we can't do that with the system account. Luckily, our administrative user does have the permission to change ACLs. So we can't read and write, but we have the ability to give ourselves the permissions to read and write, which is quite convenient. And we were looking for ways to implement that, and we found three ways. We found one thing we could do is dump the security key to the disk using administrative backup privileges. but that's not good enough for us because that's just for reading the secrets. And so changing ACLs, we found reg-ini, which is a utility that allows you for very crude changes of ACLs. Word of advice, don't test it on your own machine from experience. And eventually we came to an RPC which allows you for precise modification of ACL. So we can take the target machine and give our user the exact permissions in the registry that we need in order to perform this act. So now, enough about LSA secrets in general. If we take a look at the security questions LSA secret, we see that the plain text data is just a JSON with 3 questions and 3 answers. Not so many limitations, by the way, on length and stuff like that. You can input empty strings as questions, as you can see in this example. And if you want to locate the secret, then you do it, you find the registry key by the format, by the name L, which stands for local, AskUSA, which we assume stands for security questions, security answers, and the GUID of the user to whom the security questions belong. So if I were to change security questions on a remote machine, I would have to do the following. First, I would have to create a JSON with the questions and answers I want to plant there. Then I would have to use the RPC I've described to give myself permissions to read and write the parts of the registry I need to have access to. By using this access, I would collect the artifacts from the registry with which I can create the AES key. Then I could decrypt my own JSON and then write it to the remote machine in the right name format. And by doing that, I can change security questions and answers on a remote machine. Which takes me to the next part. Let's say I've already done that. Let's say I know the security questions and answers on a remote machine. Can I use them remotely to change the password? So if you remember, we accessed the reset password button from WinLog on screen. How do I get remote access to WinLog on screen? By RDP. But a few years back, when you would do RDP, you would get this screen, the WinLog on screen of the remote machine through which you can reset the password. But nowadays, you get this prompt, which asks for the credentials in advance. And if you look at it closely, you will not see any reset password button over there, and that's a problem for us. So we were thinking, what is that? How do we go back to this? And this is NLA. It is the latest of several protection upgrades that the RDP mechanism received over the years. RDP is pretty old. It was born in 1998. And in 2007, with Windows Vista, Microsoft introduced NLA, which allows for authentication of both the RDP client and the server in advance. And it's really bad for us because NLA does not allow you to reset password remotely. Luckily, in the negotiation phase of RDP, as an RDP client, you can specify that you do not support NLA by saying you do not support CredSSP, which is the provider which implements NLA, and thus ask the server to give you back the old WinLog on screen through which you can reset password remotely. By the way, NLA can be enforced on a machine, but earlier on, when we planted the security questions, we had access to the registry, and we could change a single registry value to remove the enforcement. So the quickest way for us to do a POC of this interruption of the negotiation is to create an RDP file which connects to the target and add a parameter saying enable CredSSP support, false. We do not support CredSSP, and by running this RDP file, we are going to get the remote WinLog on screen, which allows us to do a reset password operation remotely. Now, the last phase is we just changed the user's password, and we don't know what it was before we changed it. And if the user is active, someone is going to try to use it and notice that the password had been changed. We're going to change it back. Now, can you do an undo, Control-Z, to a password reset, password change operation in Windows? So turns out it's pretty simple. Luckily, in order to prevent people from reusing their passwords, Windows stores historic NTLM hashes of passwords that were used on the machine. Now, they are stored protected, again, in AES in the registry, but just like with LSA secrets, if you have access to the registry, it's not that hard to read them. Now, once you have the NTLM hash of the password that you just overwritten, you can use an undocumented API, SAMset information user, and reinstate the NTLM hash that was active just before you changed it, and set it as the active NTLM hash, effectively undoing the password change. So no one is going to notice that. And you can implement it with Mimikatz with simple 2 commands. And so that's it. That was our last phase. Now let's show a demo of how the whole flow works. Okay. So this is our setup. To the left, we have the screen of the attacker. To the right, we have the target. The target is, of course, a Windows 10 machine with the latest version. So now what we see is how the target changes his security questions and then uses them to reset his password. It's not part of the attack. It's just a demonstration to see the regular flow. Now he's going to input his answers for the security questions, and he can reset his password. Now, if you take a look at the attacker, then the attacker is going to change those security questions and answers remotely. He's going to do it using a Python script we wrote for the POC. And this Python script does several things that we've mentioned earlier. It's going to change ACLs on the remote machine and then create the registry, the AES key with which the LSA secrets are being encrypted on this machine. And then it's going to encrypt this JSON we have prepared and write it to the remote machine, effectively changing the security questions and answer on that machine. If we take a look at the JSON, it's the same JSON we saw before. You can try and guess what those squares of Unicode represent. We're going to see it in a bit. Now let's execute the code. All of those phases take place, and that's it. Security questions and answers have been changed on the target. Now, we are going to use those security questions and answers to reset the password. We already prepared an RDP file that does not support network-level authentication, so we can do it remotely. And by using it, we get remote access to the WinLogon screen of the target. Now, let's see, have the questions been changed? Yes, they have. Now, those Unicode squares were emojis. It was Tom's great passion throughout the project to find a way to use emojis in the security questions. Of course, the answers are all fluffy. And that's it. We can reset the password on the remote machine. We skipped. Thank you. We skipped the last part because it's pretty simple. And OK, so we have shown how you can use security questions as a stealthy backdoor, not audited and for everlasting, which you can spread quite easily without executing your own code on remote machines in the entire domain, and thus changing everybody's dogs to be fluffy forever. And now I'm going to pass the mic back to Tom.
Thank you. So Magal said that emojis were my passion. Magal's passion was the name Fluffy, which I think is a pretty cool name. And we expect from the guy that came up with the title, when everybody's dog named Fluffy will name his own dog Fluffy. Well, apparently he named it Roland, but we used this picture during the slides. So both me and Magal are security researchers, and we look at things from a defensive perspective. And it was very important to us to understand how the risk of this new feature could be minimized. And we wanted to share with you what our recommendation are to minimize that risk, and divide it into two. The first part involves Windows. We believe that it will be important to add additional auditing and GPO settings to enable better monitor of security questions, something that is currently lacking. The second thing is that we believe that it will make sense to enable an opt-out option from the security questions, specifically on Windows Enterprise. Such a feature makes sense for the home consumer. I would like my mother to have the ability to reset her password in case she forgets it. But when we talk on an enterprise environment, when you have dedicated teams to manage users, it makes less sense to enable such a feature. And lastly, if you decide to implement a security question feature in 2018, at least enable the users the ability to customize their own questions, so it make much more difficult to social engineer or maybe brute force the answers. The other side of our recommendation involve security teams, people like us, what we can do when we go back home. So the first recommendation is minimize the usage of local user. That attack involved utilizing a local user and reset its password. And generally, local users are less audited, which makes them a more prime target for attackers. And so we advise to minimize any usage of local users in an enterprise network. Second thing is to monitor the reset password event and also audit any ACL changes on the security question IVE. Both steps that we had to take during our attack, and if they will be monitored, they will raise a red flag on time. The third recommendation, which we believe is the most efficient one, is to enforce NLA in your network. As we just saw, we were able to bypass NLA by setting a specific flag. There is a GPO that enforces NLA in the enterprise. It's quite a simple one, and it is a very effective one because it prevents the entire attack. An attacker will not be able to reset passwords remotely. And lastly, because we did not find any built-in option for administrators to set, audit, or disable the security question, we created our own PowerShell script that we published on our GitHub page, and you're more than welcome to check it out. So let's review everything we covered so far. We covered a new usability feature that raises some serious security questions. We showed how this feature could be utilized by attackers to create a stealthy backdoor and keep persistence on a network. And lastly, we shared with you what are our recommendations that can minimize the risk of this new usability feature. And we have to say that as security researchers, we understand that usability more often comes in a price of security. But we believe that it's our job to understand the implications so we can make sure that everyone's dog will not be named Fluffy. Thank you very much. If anyone has any question, you're more than welcome to come and we'll...
Hi. Does this also work on Windows Server 2016?
No, it's only on Windows 10 machine.
Okay.
Anything else?
Okay. Thank you.
Thank you very much. We hope you enjoyed the talk.